Alright guys, it's Road to Genius again, and today I'm gonna be looking at an immunology topic actually. By the way, sorry about the noise in the background, or the song in the background. That's like my roommate having a good time, so to speak. So today I'm gonna be covering the immunological pathway, or rather the mechanism rather, of TLRs, or in general. With TLRs, we are toll-like receptors. And there are types of PRPs, right? P R sorry PRRs, right? Uh, Also known as a pathogen recognition receptors. So there are receptors, and they are in the immune system in many cells. And what happens is they have ligands that bind to them, or you can say that cross link with them. And these ligands are called either PAMPs, which are most of them, most ligands in the PAMPs, right? Or some DAMs, but mostly PAMPs. And if you're thinking of what PAMPs are, that things like you know, lipopolysaccharides. Sorry about that. Let me adjust the camera. Lipopolysaccharides, lipoproteins, and flagella, like the one that binds to of which actually flagellin of the flagella, flagellin. So, and there are many other types, and so those are ligands. Ligands are those are the ligands that bind to them, and they're called PAMs, or pathogen association molecular patterns. And also some DAMs also bound to the, which are also just instead of pathogen is now called danger association molecular patterns. Anyway, that's just a general overview, but that's not really the aim of this study. The aim of this study is to review the general mechanism of TLRs in when it comes to association, when it comes to the mechanism of TLRs, right? When it comes to the MYD88 pathway, because there are two pathways, right? We're going to be covering the MYD88 pathway in this study. And what is MYD88? The two MYD88 along with TRIF are called adapter proteins. So adapter proteins. Okay, there are two types. There's MYD88 and there are TRIF. There's TRIF. Okay, those are the two adapter proteins most rationally there. Now what happens is, what these adapter proteins is, they both lead to the synthesis, or to the rather to the recruit or the release of transcription factors, right? So they lead to the release of something called transcription factors, and those transcription factors include, right, things like the famous NF kappa B. So they lead to the activation of transcription factors for the production of what uh, NF kappa B. Another transcription factor is called transcription factor is called take a look real quickly. Yeah, yeah. So it's called IKR. You know. So those are the two types of transcription factors. Sorry, the MAP kinase, right? My bad. So MAP kinase. Kind of forgot that for a second. Alright, so the two transcription factors are MAP kinase and what on NF kappa B, and there are other transcription factors, because transcription factors are just things that lead to the transcription of certain things. And these transcription factors in particular, right, are there to produce cytokines. Okay, cytokines. Sorry about the writing. I kind of run like a doctor. I wish. So that's what it is. Now what happens is, these receptors are called toll-like receptors, and they have a horseshoe shape. In the which in the area they call the ectoderm, right? And they have a membrane spanning region, and this is the these little circles I'm drawing right here are called the phospholipid bilayer of the cell. And if you don't know what the phospholipid bilayer of the cell, that's called the cell membrane, so the cell membrane has this area, this particular area here of the TLR receptor. This is TLR, or toll-like receptor. This particular area here is called the membrane spanning region. Spanning region. Let me do a little bit of demarcation around here. Okay, so and this area around here is called the TIR domain. Okay, now this is what happens. They bind together when they are activated to some degree. TIR domain. Now what the TIR domain is also known as toll / interleukin like receptor domain. So what happens is that in this area is called the ectodomain, and that is it's a LRR, or leucine rich repeats in the domain. So it has a lot of leucine repeats. So that's what it means. Is leucine is type of amino acid, obviously. So it's very rich in leucine, and it's called the ectodomain, right? Now let's draw this perfectly. So around here we have the horseshoe site. Now there are two ways that the TLR could respond when it has something bound to it. Okay, and but they all have horseshoe structures, and they all form dimers, right? And the two dimers that they form are called heterodimer or homodimer, right? So either it's going to be a TLR5, because there are different TLRs. There's TLR 1 to 13, but I think TLR 1 and 10 is only for humans. I suppose I have to recheck that again. So it's TLR 5, right? And TLR 5. Okay, this is what they call an homodimer. For instance, homodimer. TLR 5 binds to flangelin, right? So that's what they call a homodimer. Okay, so the other form homodimers are heterodimers, right? So if it's TLR 5 and TLR 5 is a homodimer, however, if it's TLR2 or maybe something like TLR 1 or 6, that's what they call a homodimer. It's what they call a heterodimer. Heterodimer. So homodimers are formed when it's TLR 5 and the same TLR groups join together form a homodimer. The different TLR groups join together to form a heterodimer. Right? So when the pathogens that pump binds to this, we already told you what pumps are before, and when the pathogens pump binds to this, it generates a signal transduction pathway inside the cell. So remember, this is the phospholipid bilayer, right? Okay, so this is the phospholipid bilayer, for instance. When it binds to this, it leads to the transduction pathway into the cells, and that transduction pathway, this is the basic. Before I go into the main mechanism, recruits something called adapter proteins, either MYD88, right, or or it could also TRIF, right? So MYD88 or TRIF. and thus leads to different, different cascades. Now, um, we'll be looking at this in more detail. Okay, so when a TLR is bound, okay, let me just draw this real quick. Okay, remember, I remember when it binds that MYD88, this one leads to recruitment of other proteins, right, which leads to the activation of what? A transcription factor, either MAP kinase, or NF kappa B, NF kappa B, right? So any of these two, will be recruited and will be activated, right, to do stuff. Now let's go into the activation of both of these and how the pathway goes. And this is the main diagram. So the first thing that happens is, okay, when the pump binds here, MYD88 is recruited. That's the first step. And when MYD88 is recruited, it also helps recruit two proteins called IRAK4 and IRAK1. And together, they are called the mydosome. Sorry, this one S there. Mydosome, right? There's two D's, one S. My bad. So they form the mydosome complex. Now, in this mydosome complex, TLR4, IRAK4 is able to activate, right? We're going to go into the full names later, but IRAK is a kinase. It's able to activate IRAK1 by phosphorylations. Whenever I draw this P, to T is phosphorylation, P. And the activation phosphorylation process is known as multiple site O2 phosphorylation. Okay, so multiple sites O2 phosphorylation is what leads to the phosphorylation and activation of IRAK1. Then IRAK1 leaves the mydosome. Just in case you didn't understand what that was. It leaves the mydosome. This is not IRAK1 free. Okay, IRAK1. So IRAK1 leaves the mydosome, right, and goes ahead to activate something called what? A very important protein called TRAF6. And it's a kinase, so guess what it does? Well, it activates it by kinase, by phosphorylating it, right? So it's a kinase that activates TRAF6 by phosphorylating it, and TRAF6 is also known as what? A ring domain E3 ubiquitin ligase, right? So it's a ring domain E3 ubiquitin ligase. So this thing tells you something. It's a ligase that does what? Ubiquination. So when TRAF6 is activated, and if you don't know what ubiquination is, it's just sticking a ubiquitin group on top of a protein, leading to the protein destruction. So when it's activated, it goes ahead and it binds with a complex. It forms a complex, with two other proteins. Okay, and these proteins are called UEVI, okay, or UEVIA, and UBC13, and this is of course TRAF6. So in this complex, first of all, in this complex formation affects TRAF6 and another protein called TAC1 in this case. And TAC1 is bound by certain anchor proteins called TAB1, TAB2, and TAB3. Haha, brilliant, right? And they anchor it, so the anchoring of this TAC1 stops its release and stops his ability to do his job. So what happens is this complex leads to two things. It first of all leads to the ubiquination. I'm going to draw this black as what it leads to there. So maybe I'll draw as an arrow, right? My bad. So it's going to cause the ubiquination of these three proteins. Now, what did I tell you what ubiquination does? It sticks a ubiquitin group on them. So it's U for ubiquination, U and U. And sticking a ubiquination group of them, what leads them? It leads them, or it leads them all to what? To be broken down in the proteasome. Okay, this is a proteasome. Okay, and when they're broken down in the proteasome into other amino acids and products, amino acids and products, right? So they get broken down in your proteasome. Guess what happens? This then leaves and is free. Now, when TAC1 is free, oh boy, it does several things. It does two things, and this is where the story becomes a little bit more interesting. When TAC1 is released, it can go into two places. It can either go into the NF kappa B pathway, okay, to activating NF kappa B, right? Or you can go into where? Or you can go into the MAP kinase pathway. The same thing, activating MAP kinase. Sorry about that, guys. So it can also activate MAP kinase, right? So these are two different pathways. We're more interested in the kappa B though. Because MAP kinase, what happens is when it goes on to activate MAP kinase, it TAC binds. Okay, this is TAC. Right? It binds directly to a MAP kinase. So yeah, figure. And the types of MAP kinase can either be the type kinase it binds to. Examples of them are P38, JNK, and the affectionate ARK 1/2. We're going to focus on all these things later, but these are just the different MAP kinases that exist. I'm sure there are more, obviously, because biology is never certain. So it goes ahead to activate these ones, and it then goes ahead to the cytoplasm. And when it goes to the cytoplasm, okay, this is the cytoplasm. I'm going to make this a little bit lining. Okay, it goes ahead to transcribe. It binds to its promoter region on the, okay, on the, you know, gene of interest, then leads to the transcription of mRNAs of cytokines. We're going to go to that process more in detail later. We're just looking at the overall, you know, process. So now, that's for that. This is transcription. Okay, so this is transcription. Okay, so on the other hand, the one I'm most interested in, you know, is the binding of how, or the release of NF kappa B. So for the NF kappa B pathway, what happens is the TAC1, you know, goes ahead and forms a complex. Forms a complex with what? Several IKK proteins. Okay, so this is TAC, and this is one protein of an IKK, you know, called what? IKK alpha. Okay, I wonder what the next protein will be. IKK beta. So you might be thinking, okay, the next protein will be IKK gamma? No. Well, yeah, IKK gamma. And IKK gamma will be also called Nemo. Like if you think of IKK gamma, just think of Finding Nemo, you remember it. So it binds to that, and when binding to the complex, this leads to the activation of only one IKK for now, called IKK beta. And I wonder how it activates that. By phosphorylation. When you see Ks, you must be aware that they might be kinases, right? So it activates IKK beta, and IKK beta goes ahead to bind something called IKB alpha. Actually, is IKB alpha, right? And IKB alpha is, it's not the same thing. This IKK beta, this IKB alpha. So IKB alpha is bound to what? The precious NF kappa B. Sorry. So this is the precious NF kappa B, and precious NF kappa B is just doing its own, doing its own thing, inhibited. So this protein inhibits NF kappa B, and the binding of IKK beta to IKB alpha releases NF kappa B. And what happens is it leads to the phosphorylation of this, because it's a kinase, it does that. And for some reason, this phosphorylation also further leads to the degradation of IKK, which is funny, and it's done that by the proteasome, which is a funny process. Anyway, so it binds to this one leaves, and for some reason gets degraded, and so this one is free to go. And guess where this one goes? Of course you guessed it, just like its friend. It's a adapter protein. It's a transcription factor. So naturally, when you hear a transcription factor, they're going in to do what they do best, initiate transcription. So it goes into the nucleus, okay, and it binds to the promoter like its counterpart and promotes transcription, mRNA transcription. Okay, and that is the whole process. So if you have a problem, there's a reason I went slow, because If you have a problem remembering down them, all of them, just go through them bit by bit. Now to go around over it, in a very quick way, with my band handwriting, just so you get the point of on summary of what happens, right? When it comes to this, right, my D88 pathway, my D88 binds to the TIR region of the. Oh, I forgot to do that. So it binds to the TIR region, right? I think I did that in the previous one anyway. So it binds to the TIR region of the toll-like receptor. Then when it binds to the TIR region of the toll-like receptor, that it recruits something called IRAC4 and IRAC1. And the recruitment of IRAC4 and IRAC1, leads to the activation of IRAC1 and together this complex is called the midosome, by the way, and it leads to the activation of IRAC1 by something called the multiple site autophosphorylation, right? And that leads to the release of IRAC1, and IRAC1 goes ahead to activate TRAF6. And TRAF6 is a ring domain E3 ubiquitination ligase, right? Now, this activation of TRAF6 by phosphorylation as well, because leads to the binding or formation of a complex, of TRAF6 and other proteins called UBC13 and UEVIA, and this complex leads to the breakdown of. By the way, I forgot something. This complex, right, also leads. My bad. I made a mistake by forgetting. This complex also leads to the breakdown or to the ubiquination of TRAF6. So that means TRAF6 as well as these proteins all head to the proteasome, right? So when this complex binds goes ahead to ubiquinate tab1, tab2, and tab3, right? Tab1, tab2, and tab3 are then released from TAC1, and all of them, as well as TRAF6, going to be broken down into amino acids by the proteasome because they're being ubiquinated by this complex. And then TAC1 is free, and TAC1 goes ahead to do what TAC1 does. TAC1 do. So, sorry, dry jokes, oh my god. Anyway, so TAC1 goes ahead and activates and releases NF-kappa B or MAP kinase. And how does it release NF-kappa B and MAP kinase? Well, MAP kinase just frankly binds to MAP kinase, and MAP kinase goes into the nucleus and stimulates transcription of our mRNA. I'm sure there are other processes involved. I will dig deeper into it to find out other processes. As for this, as for NF-kappa B, TAC1 goes ahead and binds to a complex called IKK gamma, IKK beta, and IKK alpha. Now, IKK gamma is also known as NEMO, by the way, and that leads to the activation of IKKB. And IKKB goes ahead to bind to IKB alpha, right? So IKK beta, right, that goes ahead to bind to IKB alpha, right? And IKB alpha is an inhibitor of NF-kappa B. And when they bind to IKKB and phosphorylate it, IKKB alpha then, and so IKB alpha then leaves. Just look at the diagram if I'm making a lot of stupid mistakes. Leaves and gets somehow degraded. Then NF-kappa B goes ahead into the nucleus and stimulates transcription of RNA, mRNA, of what? Cytokines. So don't forget, the cytokines are the product. That's what the cell is trying to produce. Cytokines help you fight. They're the product, right? So IKK being the product, are the ones of are the stuffs of interest, and because they're the things of interest, they are the ones that get produced by the whole process. So all this process is just to lead to the production of IKKB. That's it. I mean, of cytokines. My bad. And okay, that's that. Thank you. I think I'm out of time. Bye.